Hello, and welcome back. Today, I will be looking at one method to measure the velocity factor and characteristic impedance of a coax cable using a VNA and a tape measure. So if you're curious, then keep watching. Normally, both these parameters, the characteristic impedance as well as the velocity factor, are written in the datasheet. But there is always some amount of tolerance. So if you need more precise values, you must measure the exact cable that you have. So first things first, the cable needs to be connected to a test connector, and the exact cable length will then be measured. The longer it is, the less the exact connection point will matter. So this bit here with the connection has a different impedance and different propagation velocity. So you want this connection bit to be as short as possible to minimize the impact on the results. So anyway, the resulting structure I got is a 103.5 centimeter long piece of white coax cable. Next, after going through the steps of calibrating the VNA, we need to observe the open circuit resonance points. These will help us determine the exact propagation velocity. So what this test shows us is the frequency where the cable is exactly a quarter wavelength long. With this cable, the measured value is occurring at 58.2 MHz, and this equates to a propagation delay of 4.29 nanoseconds, which can be converted into a delay constant of 4.14 nanoseconds per meter, and from this you can determine what length you need for a specific delay. Also, we can determine the propagation velocity, which in our case is 80.4% of the speed of light. So depending on your use case, one or the other of these values will be needed. Next, to determine the impedance, we will make an S11 parameter measurement starting from 100 kHz up to 500 MHz. And while I'm using the maximum number of points this VNA has, 1001. Then this measurement needs to be saved as an S1P file and moved to a computer. For this, I will be using the S2 VNA program from Copper Mountain, which is free, and there's both a Windows as well as a Linux version available. So once the program opens, we need to load the file. So this goes from the Save Recall menu, load data from Touchstone to S parameters, and after selecting the file, you just let the program make its necessary settings. So now we loaded our S11 file, but we need to change the way in which it's displayed and how it's analyzed. So first, we go to the Analysis menu, activate Time Domain, and make some settings here. So we want reflection type one way, and we can adjust the exact displayed interval, going from 0 to just above our cable length, so 5 nanoseconds. If you don't like time units, you can always change to length units. But anyway, last thing to set here is the type of analysis, which will be a low-pass step type. So now we can go back all the way to the Analysis menu and also enable Conversion. So we leave it at Reflection type Impedance. Finally, it's time to adjust the displayed values. So we don't want logarithmic magnitude, we want linear magnitude, and we can change the units per division to, let's say, 10. And then pull our waveform into view. So this is our time domain reflectometry measurement on our cable. And we can see we have a stable plateau somewhere around 90 ohms. So right at the beginning we have the connector, and right at the end is the open end of the cable. That's why the value shoots up. Now, if we want a more accurate measurement, we can always go to the Markers menu, add a marker, and just play around with it on the waveform and observe it on the upper corner. Of course, we can add multiple markers if that's what we need. So anyway, our cable is somewhere in the 90.8 ohms to 92 ohms in characteristic impedance. The value increases because the cable losses start to stack up. So somewhere at the beginning in the flat region is where we can make a good measurement. And there you have it. This 75 ohm 66% cable has a velocity factor of 80% and a characteristic impedance of 91 ohms. Now, this is quite an extreme case, normally you don't get this, but regardless, knowing these two parameters can be quite important depending on the circuit that you're working on. So being able to measure them is a good skill to have. And with that said, hope you enjoyed this video. See you next time. Bye bye.